Okay, we're going to do one more system where we look at things from a static point of view and then make a comment about if we had measured, let me rephrase that. We're going to measure everything from an unstretched position, then we'll make a comment about if we had looked things from the static equilibrium point. So here's the system we're going to be looking at. We'll put this right here. Get another page in to help me out. There we are. So we have this box-ish type thing hanging by a spring. And we're going to do this first, and suppose we're measuring it from the unstretched position. And within this box, there is another box, which is connected to the top of this box by a spring in the bottom. Both boxes have mass. So here's M1G, here's M2G. We have a force. Now, this is not a static force because it's something we can pick. It can vary in time. It's something that it does change. We can turn it off and turn it on. Gravity, you cannot turn it off and turn it on, and it does not change. Okay, so both of these measured from the unstretched positions of the springs. Okay. And then we have damping here on the sides between these things. All righty. So when we go to do this, again, we'd use our push-pull method. So ODE is from undeflected reference positions. Okay. And so we have, so to do this, we have to do a model for M1 and M2. So we would do this the same way. So if I hold M1 still and I take, or said that wrong, I'm going to do the equation for the first mass. I'm going to start by holding M2 still, and I'm going to move M1 in a positive direction and ask the question, what does it feel? Okay, if I move M1 in a positive direction, K1X1 will oppose it. K2X2 will oppose it. I move this in the positive direction, K3X3 will be pulling it back up. If I move this in a positive direction, notice I have this is B over 2, that's B over 2, so they had to be. But as this moves down, B times X1 dot will oppose it. But F and MG will help it. All right? So that's what we have, all of these terms. Okay? Lots of opposition, but these two helping. Now, to finish the equation for M1, I hold M1 still and move M2 or any other mass connected to M1. And so I move this in the positive direction and say, what does this feel? As I move this in the positive direction, this will have a K2X2 pull down. It'll have a K3X2 push down. And then it will also have a pull down from B X2 dot. And that's what we have. And of course, we can regroup all the terms this way. Put all the X1s here, put the outside forces here, and the other mass on the other side. It's reasonable. Okay, now I got to do the same, do a model for X2. All right, so for X2, we'd we'll hold this still, and let's say we hold M1 still and move M2. If we do that, if I move M2, holding this still, K2X2 will oppose it, K3X3 will be opposing it, pushing up, and BX2 dot will be also opposing the motion. And that's what I have here. And we note we do have its weight, M2G, helping along. All right. And then if I hold this still and move M1, you have K2X1 pushing down, K3X, I don't know if I said that right, K2X1 pushing down, K3X1 pulling down, and B times X1 dot pushing down. And that's what we have there. All right? And this has a mistake. fix that. So we had all the x1 stuff pushing in the positive direction, the k2 stuff opposing it, or the x2 motion opposing, except for the m2g. Now that's corrected. All right. Now then we can bring the x2 stuff, group that all on the other side. We leave the x1, say, here, and there's another mistake. M2G. So this is based on measuring from the undeflected positions. Now, if we were to be measuring instead from the undeflected position from the static equilibrium positions, how would these equations change? So we'll put a hat on this stuff just to emphasize we're measuring it from different points. There's a hat missing here. And basically the only difference is the equations look all the same, except you would simply, M1G and M2G are now simply gone. All right. So these X's all represent undeflected, whereas these X hats represent measuring from the static equilibrium position. It's the same process to get the differential equation. We just ignore gravity. And we're obviously measuring from a slightly different spot in each case. So there that is. We will hold off on that, and we'll see you again soon.